simple rational functions, and remember rational means able to be put in a fraction, so these are going to be functions that are fractions where you're going to have an x maybe either in just the numerator or denominator or both. So the parent function of a simple rational function is 1 over x and is called a hyperbola. So a hyperbola consists of two symmetrical parts and they are called branches. So that's these guys right here. Those are your branches. And if you notice, they're both in opposite quadrants or diagonal quadrants, and that's always going to be the case for your branches. So the domain and range are all non-zero real numbers. So in this case, it can't be 0 because x is in the denominator, and you can't divide by 0. So as we start to add or subtract or multiply things, that will change, but it's still going to be the same idea of the fact that you can't have 0 in the denominator. So I did sort of give a key box down here, and once we do start adding and subtracting or multiplying things, the domain of these functions, remember domain is from left to right, is going to be from negative to positive infinity, but it's going to skip over that vertical asymptote in the middle. And we said that's where you use the u. And the range from bottom to top will skip over the horizontal asymptote. So this one actually will have two asymptotes. It has a vertical and it has a horizontal. It will have two asymptotes that intersect on a single graph. So the first example asks us to graph the parent function 1 over x, and then also it says using a colored pencil. So if you guys have like a pen or a highlighter or something that's not a pencil, you could use it to graph 6 over x. So the first one I'm going to do is 1 over x, and I'm going to do that one in green. So I just went ahead and you guys can do the same. Put 1 over x into your calculator and just pull some points off of the table. That's fine. And as you can see, we have two branches. One is in quadrant 1 and the other one is in quadrant 3. So now the second function I'm going to do is 6 over x, and I'm going to do that one in pink. So now I've graphed the function f of x equals 6 over x in pink. So it wants us to identify the vertical asymptote, horizontal asymptote, and the domain range. Now, because nothing's actually being added or subtracted, that's when the asymptotes get moved. So because nothing's being added or subtracted, they're actually going to be the same for both. The horizontal and vertical will both be at 0. So the vertical asymptote is through x or through y equals 0. And the horizontal asymptote, and actually that's going to be through x equals 0. Vertical goes through x, and horizontal goes through your y value. So the domain and range for both of these is actually going to be negative to positive infinity, but we're skipping over 0. So remember, that's what that u means. So when you have a number with parentheses at that u, that means we're coming as close to that value as possible, but actually skipping it and not including it. That's all that's saying. So we're going from negative to positive infinity, skipping 0. The union, or the U, is where you have the gap. So if it asks for a comparison, the only thing that happened here is 6 over x. The asymptotes are the same, domain, range, both the same. The only thing that changed is that 6 over x is stretched further from the origin. So as your numerator gets larger, this point will get further and further away from that center of your asymptotes, or the origin of your graph. So before we try and graph one of the main examples, let's just look at trying to find the information first. So if we look at number 3, it says f of x equals 2 over, or 2 divided by, x minus 1 minus 4. So the locator point, that's the origin of your asymptotes per se. It's sort of like the center of your graph is kind of moving. So that's going to be based upon the value being added or subtracted in your denominator, and the value being added or subtracted in your, or out by itself. So what happens if you guys have your plane here? And actually, let me move that over. The locator point is going to move to the right 1 and down 4. So right there, we would say. So the number in the denominator is opposite. The number on the outside is the same. Denominator is your horizontal shift. Number on the outside, your vertical shift. So that locator point would be at positive 1, negative 4. That's where your asymptotes should intersect. So your vertical asymptote goes through positive 1, and your horizontal asymptote goes through negative 4. So the domain matches or goes with that vertical, and the range is going to go with that horizontal, because range is from bottom to top. So if we take a pencil and lay it on your paper, as you move it up your paper, it's skipping over that horizontal asymptote. The domain, as you move left to right, would skip over the vertical. So your domain is going to be from negative to positive infinity, but we're skipping the value of 1. The range will be from negative to positive infinity. We're skipping the value negative 4. So negative infinity to negative 4, parentheses, don't include it, skip over it, start right there at negative 4, and keep going. So that's it. So for the simple rational functions, that's pretty much going to be your baseline each time you do these. So let's go ahead. You guys can try that other one. I'm going to go ahead and graph one on the other page. So for number 4, we've got 1 over x minus 3 plus 2. So the first thing I always like to do is just draw in my asymptotes. So I know that my asymptotes are going to be right 3, so the vertical will be at 3, and the horizontal will be at 2. So just don't get them confused, guys. Because when you go to graph them, if you get the horizontal or the vertical mixed up, like you know what they're supposed to be, but you graph them incorrectly, then when you go to plot your points, you'll have like some that are on this side of the asymptote, but they're supposed to be on the other side, and it gets really confusing just because you simply screwed up the vertical or confused yourself with which one was vertical and which one was horizontal. So just don't get confused with that. So, vertical asymptote will be at 3. Horizontal will be at 2. And I did it again. Got my X's and Y's mixed up. Vertical goes through your X. And horizontal goes through your Y. Okay. So, I do need points here. I understand that. I get that. But I know before I even graph it, guys, that my domain is going to be from negative to positive infinity, but you're skipping over that vertical asymptote, which is 3. So it's going to be from negative infinity to 3, union 3 to positive infinity. That's going to be my domain. And then my range from bottom to top is going to be every single value except my horizontal, which is 2. So negative to positive infinity, skip that value of 2. For these simple rational function, that's how it's always going to be. So now I just need points. So what I would do is put it into your calculator. This will be on the calculator portion of your quiz and test. Now when you graph it, it needs to be y equals, just to get in good practice, at this moment you don't really need the numerator in parentheses, but just out of good practice, numerator in parentheses divided by denominator in parentheses plus 2. If you don't do those parentheses, guys, and you just do 1 divided by x plus 3 minus 2, it's going to do 1 divided by x, and then add negative 1 to whatever that value is, because that's what negative 3 plus 2 is. So if you want that denominator to be a whole expression within itself, in the denominator, it has to stay within those parentheses. So just remember that as you guys are graphing. Now when I pull up the graph, again, we don't need to go crazy here with the points, guys. Like 2 points per branch is fine with me. So I see that 4, 3 is a point, 2, 1, 5, 2.5, and 1, 1.5. So let's see, 4, 3, 2, 1, 5, 1, 2, 3, 4, 5, 2.5. And 1, 1.5. So again, as long as you know the general idea of what these should look like, you guys don't have to go crazy with the points. And then just draw in each of your branches. And again, you can make them big, small, it doesn't really matter. But they should not ever cross those asymptotes. At this point, with the simple rational functions, at this point, they don't ever cross the vertical or the horizontal. So, and remember, guys, if there are no values here within your denominator or only by itself, if there's not a value there, then that means the value is 0. We just never write plus or minus 0 because it keeps the value. So if you don't see something there, then that means okay, we still have one, it's at 0. So just keep that in mind. Don't forget you can always put those fillers in to help you out. So go ahead and try number 5.